Okay, class, we back. Let's talk about row echelon method. That's like putting a matrix in a triangular shape. Okay. Row echelon is when you have one on the diagonals and everything underneath is zero. Let me split it again. Row echelon, it has to be one, has to be on all the diagonals, has to be on all the diagonals. That's just how it is. It has to be. So when it's like that, it has to be zeros at the bottom, row echelon form. Okay? And it does, you think about it, it does form a right triangle. Look, forms a triangle, it's a right triangle. So it has to be that way. Now, when it's in row echelon form, you all, we can solve by hand by doing what we call back substitution or substitution method. What I mean by this is on this row, anytime the very last row, if it's in row echelon form, that very last row, that last variable will always be solved for. So like, look at this one right here. In this row, it was Z. I'm going to call it Z. Z equals 4. So we know the very last variable. So what we could do, and like I said, it's called back substitution, or make math like I say, it's just substitution. What we do know is that because I know Z, guess what I do? I can take Z and plug it in the second equation, and that'll let me find the second variable, which is Y. Once I find Y, I got Y and Z. I can take those two and plug it in the first equation and solve for the first variable, which is X. So you're going backwards to solve it. So that's why it's called back substitution. Now, you all could write this down, pause it and write it down. But let's try some here. Let's try some. Now, look what I say. Each augmented matrix is in row echelon form. Use back substitution to solve the systems if possible. So, you all, it should be, let me highlight it. Look, row echelon, I only got 2 rows. Look at this, I got 3 rows. Let me highlight it, it's just 2 here. And I need to talk about this for a reason, okay? Let me put this here, because I like to do that to separate my constant column. Now, we're doing back substitution. Remember, if there's diagonals on this row right here and everything underneath is 0, which is correct here, then this last variable is already solved for. So if you see, you only have 2 variables, 1, 2. So that could be X and Y, right? So when I write these equations, I get X minus Y equals 2 here. But look at the second equation, I get Y equals 0. See, this is already solved for. So all I got to do is plug this in right here, and I get X. So when I get that, when I plug that X minus 0 equals 2, we get X equals 2. Let me say this from from 9.1. Remember, all your answer has to be as an order pair. So do not write X equals 2, Y equals 0. No, it has to be an order pair. So our order pair is 2, 0 here. This would be our answer. Okay. Next thing. Y'all see we have a 3 by 4. You see how many equations we have? We got 3 equations. But look at this bottom one right here. See, this last one is already solved for. So if you got 3 equations, look, you're going to have 3 variables. Let's call that X. Let's call this Y. Let's call it Z. Let's write out these equations. Let's write it out. Look, we get X on the first equation, X minus 2Y minus Z equals 0. That's the first equation. Let's do the second equation. We don't have no X, right? So then we get Y minus 3Z equals 1. Last equation, look, we don't have an X or a Y because both of them go to 0. And then we just get Z equals 2. This is what I mean. This very last equation is going to, last variable be solved for. Z is already solved for. So guess what I could do? I can solve for Y. I'm going to take Z, plug it in here. Look what I get. Y minus 3 times 2 equals 1. I get Y minus 6 equals 1. When I add 6, I get Y equals 7. So we got 7 for Y. You know Y and you know Z. So guess what you can do? Take both of that information, Y and Z, plug it into the first equation to get X. So let's do it. X minus 2 times Y minus Z equals 0. I get x minus 14 minus 2 equals 0. That's x minus 16 equals 0. X is 16. Now, once again, remember your answer is an order pair, not x equals y equals. So you go in alphabetical order. X is first, right? 16, then 7, then 2. This is our answer. It's just three-dimensional. Now, you all, I gave number 7 for a reason, okay? Number 7 we have for a reason. Because one thing I wanted you to see is this triangle does not go all the way down. I mean, this diagonal of ones does not go all the way down. It stops. But the key thing here is this row right here. This speaks volume. If I had to write an equation for that row, this row would be 0 equals 0. That's what you would get. Because everything on the left goes 0 and the right side is already 0. That's what we get. So that really says that when you look at that, all these equations, which all the rows, are identical to each other. That's what it really says. But you got to write your answer correctly. My math lab was going to say, write it in terms of Z or Y, just depending on what they ask you for. But it's usually you write your answer in the form of an expression of the last variable. So like again, let me write this. This would be X, this is Y, this is Z. What it wants you to do, you all, is because, and that's when this row looks like that. So you don't do this other than that. It wants you to write each variable as an expression of Z. Let me say it again. It wants you to write each variable as an expression of Z. That's how you write it. So let's write these equations up first, okay? If I write this first equation, I get X minus Y, minus Y plus 2Z equals 8. Second equation is going to be X minus 4Z equals 2, right? That's what it'll be. That's what it's going to be. There's no, I already got the equation for the third one. Okay, we can't do anything with that. So what it wants you to do, sorry, I meant to say Y right here. I apologize, Y right here. Y, I wrote X, but I meant to say Y minus 4Z. It wants you to take, you got to start with this second equation right here. Solve it for Z. That's what it wants you to do. Solve it for Z. Okay? Now, I meant solve it in terms of Z. I apologize. Solve it in terms of Z, where you have Z left. That's what I mean, not solve for Z. Sorry, I was saying it wrong. You want to solve it in terms of Z. So you want to solve Y where you get Z on the other side, in other words. So if I solve this way, I get Z. All I got to do is add Z. So I get Y equals 4Z plus 2. Now, whatever variable that I want to solve for, I do want it on the side by itself. So let me make sure I correct that, understand that. I now have Y by itself, but it's in the form of Z, right? Because Y now equals to something with Z in it. So that's what I mean by in the form of Z. So we have that. You all, the next thing I have to solve is I got to go back. Remember, back substitute, you got to plug this in here. Where I see Y, I got to plug this in. Now I got to solve X in terms of Z. Okay? So let's do it. We do X minus where Y is, and I got to put parentheses around that. This is what I plug in because Y is right there. Plus 2Z equals 8. I mean, that's what I got to do. Now, distributive property, X minus 4Z minus 2 plus 2Z equals 8. X minus 2Z minus 2 equals 8. Now, I want X on the side by itself, but it's going to be in terms of Z. So let's do it. X equals 2Z plus 10. Okay, that's what I get. Okay, I still have X by itself. That's what we want. So, you all, each one of these expression now becomes part of your answer. You still got to write it as a point. You cannot leave it like this. So the first point would be this expression. So not the first point, but the first variable will be with this expression. It's in the term of z. That's what you want, just that expression. The next one is 4z plus 2. And then when you get to the last one, you just write net variable. That's all you do. That's all you're doing, because wouldn't z be right here? But we just have this equation, 0 equals 0. Now, what's next is going to be calculator. So make sure you get your calculator ready.